This video looks like the ions and types of bonding. We will look at specifically ionic bonding and do covalent and metallic bonding in subsequent videos. Now, so here we have ions. Now, we know generally atoms will want to have full outer shells. Okay. However, in most cases, their atomic number means that they will not have full outer shells, and so they will have to either lose some electrons or gain electrons in order to have full outer shell. Now, when they do that, they become ion and possesses charges. So an ion is a charged particle, okay, and atoms become charged when they loses or gain an electron in order to have a full outer shell. So ions are charged because the number of protons is different from the number of electrons. Now, what do we mean by this? Now, we know that the number of protons is always the same as the number of electrons. And so if you look at sodium here, sodium has an atomic number of 11. And so its configuration will be 281. What it means is that there is one electron in sodium's outer shell. Sodium will therefore have to lose this one electron in order to have a full outer shell of 2 shells. Now, when sodium does that, it becomes sodium ion because it will then possess a charge of +1 here. Okay, so sodium atom has 11 electrons. It loses the one outer electron and become 2,8, in which case it will have a full outer shell. Okay, so atoms become ion when they loses 1 or 2 electrons from their outer shell in order to obtain a full outer shell. Okay, now we also have molecular ion, which is a particle made of more than one atom that has an overall positive or negative charge. So, for example, we can have CO3 minus, and we know that this is a carbonate, and they all have what? -1 charge. We also have SO4, which has a charge of -2. You've got to be able to learn all the other polyatomic ions and know their charges. Okay, now so here we have a negative ion is called anion, and a positive ion is called cation. What do we mean by that? An anion is an atom with a negative charge. So here this could be an anion because it possesses negative charge. Sodium ion is a cation, okay, because it's a positive ion. Now, so ions are formed when atoms loses an electron from their outer shell in order to have what? A complete outer shell. Okay, now let's look at how they form that. I've already explained to you how atoms form negative and positive ion. Now let's look at forming negative ion here. Atoms gain electrons in their outer shell when they form negative ions, and they become anions. Now these ions are negative because they contain more electrons than protons. So let's look at oxygen here. They become -2 by gaining 2 electrons. Why would they gain 2 electrons? Let's look at oxygen atom. Oxygen atom has 6 electrons, which is 8 overall. Okay, so the outer shell contains 8 electrons. It needs 2 more in order to complete its outer shell of 8 electrons. So what oxygen does is to receive 2 electrons more and become -2, in which case it will have electronic configuration of 2,8. Okay, so here we got the extra electron that oxygen receive in order to become -2. Okay, so atoms become negative ion by accepting electrons. If they transfer or donate electron, they become positive ions. Let's look at how they become positive ion. Atom loses electrons from their outer shell when they form positive ion called cation. Okay, so cations are formed by the loss of electrons from outer shell, and anions are formed by the gain of electrons to the outer shell. An example of anion is the oxygen we just looked at. Let's look at an example of cation, which I've already mentioned, is sodium, because sodium has 1 electron in its outer shell. It gives that out and become Na+, in which case it will have electronic configuration of 2,8. It will get rid of this one here and become 2,8, and that is an example of cation. Pause the video and write down the electronic structure of other cations you know. Pause the video and write the electronic configuration of other cations you know. Okay, so let's look at other examples here. We got here group 1. What you need to know is that the group that an element belongs to determine the charge on it. So here we got group 1, and example is sodium. Sodium will therefore have a charge of +1, and the symbol will be Na+. Again, if you go down, we have group 2 element. Example is magnesium. Since magnesium belongs to group 2, the charge on magnesium will be what? 2+, and the symbol of magnesium ion will be Mg2+. And if we go down, we have group 6. Example is oxygen. Oxygen will take 2 normally to complete its outer shell, so it will be -2, and that will be the symbol of oxygen ion or oxide ion. Now the next one is group 7. Since it's group 7, it will have 7 electrons in its outer shell and will therefore need 1 electron to complete its outer shell, and so will be -1. Example is chlorine, and we have chlorine minus, and that is example of some of the ions that you need to be aware of. Now what you need to know is that when you are writing the symbols, you've got to make sure that you write the number before the positive sign or positive or negative sign. For example, if you are writing sodium, you write your sodium, and sodium is 1+, so you just write the sign. Now if you want to write magnesium, you write your magnesium, write your number before the sign. Okay, if you want to write the ion for chlorine, we write our chlorine, and then because it's -1, we just write our sign. What about oxygen? We write our oxygen, we write our number followed by the sign. Okay, so that's how you write the symbols for the various ions. Now, with the knowledge of ions, let's look at bonding and look specifically at ionic bonding. Now there are 3 types of bonding. Okay, there are 3 types of bonding. We've got ionic bonding, covalent bonding, and metallic bonding. Now in this video we will look at ionic bonding. Okay, let's look at ionic bonding. Now ionic bonding occurs in compounds that contain a metal, usually group 1 or 2 element, with the non-metals, usually group 6 or 7 element, and they form bond and form compounds that are metals. Okay, so ionic bonding specifically happens between metals and non-metals. Okay, group 1 or group 2 metal and group 6 or group 7 elements. Okay, so that's how ionic bonding. Let's look at how the bonding comes about. Now, when forming ionic compound, electrons are transferred from the metal atom to the non-metal atom. Okay, so electrons will be transferred from the metal, and the non-metal will receive the electron, and therefore the metal will be positively charged and the non-metal will be negatively charged. This form oppositely charged ions. The metal ion has a positive charge, the non-metal has a negative charge. An ionic bond is the attraction between these oppositely charged ions. Ionic bonding is strong and requires substantial amount of energy to break. Now, what are we saying here? Ionic bond form, first of all, is formed between a metal and non-metal. Now, how does it come about? We know that metals loses electrons in order to complete their outer shell, and non-metals receive electrons in order to complete their outer shell. So if we take, for example, sodium. Sodium loses 1 electron from its outer shell and become 1+. Chlorine have 7 electrons in its outer shell, and therefore we will take that electron from sodium in order to complete its outer shell and become -1. We therefore have a situation where we have a positive charge here and a negative charge here. Remember that positive and negative charge attract, so there will be an attraction between this positive charge from sodium and the negative charge from chlorine. It is this electrostatic attraction between the positive charge and the negative charge that is called ionic bonding. So ionic bonding is the electrostatic attraction between the oppositely charged ions of metal and non-metal. Remember, one characteristic properties of ionic compounds or ionic bonding is that it has high melting point and high boiling point. Okay, so because of this attraction, you require loads of energy to break the bond, and that's why it has high melting and boiling point. Now let's look at some examples and how we represent ionic compounds. You've got to learn the dot and cross diagram of some specific ionic compounds. That is important for your GCSE. You need to be able to draw the dot and cross diagram of sodium chloride, magnesium chloride, calcium chloride, and other compounds. These are basic compounds that tend to come in exams. So how do you go about drawing dot and cross diagram? Draw the electronic configuration of each atom, okay? One element with dot and the other with crosses. So you first of all, draw the electronic configuration of the atoms, and then we go on and work out the ions, okay? Then the second step is to work out how many electrons need to be transferred. So let's use this sodium chloride as an example. We've got sodium chloride. This is the ion, okay? It has lost 1 electron, and so it has become sodium 1+ ion. Chlorine received that electron, and that electron from sodium is here, okay? And chlorine become -1. There is therefore an attraction between this positive sign here and the negative sign here, and so that creates a bond between the sodium and chlorine, and we end up having sodium chloride. Now let's look at other examples here. Here we got magnesium chloride, magnesium oxide. We got the atoms. The first step, you write the atoms. We got the atoms here. You can see that magnesium have what? 2 outer electrons that can be transferred, donated. However, oxygen have 6 electrons in its outer shell. It needs 2 electrons to complete it. So oxygen will take those 2 electrons from magnesium in order to complete it. So first of all, we write the atomic structure, and this enables us to work out how many electrons need to be transferred and therefore determine the charges on the various ions. Let's go here. These are the ions for magnesium and the ion for oxygen. So here, magnesium has lost the 2 electrons and become 2 plus, and oxygen has received the 2 electrons and become 2 minus oxide. So that is the dot and cross diagram for magnesium oxide with the formula of MgO. Okay, because oxygen originally have a charge of -2, magnesium have a charge of 2 plus. Now you see that this compound will have overall charge of 0. Okay, so that's how they work out to form the dot and cross diagram. Let's look at this one too. This is calcium chloride. Calcium has 2 electrons in this outer shell that can be given out. Chlorine, on the other hand, have 7 electrons in its outer shell. It can only take 1. So what does chlorine do? He calls his brother to come in. So we have 2 atoms of chlorine. Each one of them is going to take 1 calcium electron. Okay. And in doing so, each of the chlorine atoms is going to have complete outer shell, and we will have a compound calcium chloride to have what? CaCl2. Now what this means is that we have 2 atoms of chlorine bonding with what? 1 atom of calcium in order to complete their individual outer shell. And this is the dot and cross diagram of calcium chloride. Now in the next video we will look at other compounds and look at covalent compound.